So this is part two, continuing from where we left off. I was saying there are millions of words out there, but if we don't like the selection, we can try again. Global Sultan upmixed, yeah. So basically, this is pulled from, like I said, tens of millions of words, including AI-generated words, and they're all easy to remember, easy to pronounce. So we run linguistic rules on them, and we filter it down to maybe 16 million words, out of the, many, many millions of words, pronouns, brand names, fictional names, you name it, acronyms, all of that. So we narrow it down, to about 16 million. And from that, we get 24 bits of entropy per word. And so basically, it's all about the random choices that the program has to make that constitute the entropy level. So let's say we go with this one. Let's see what we've done. In this effect, we rendered this. If I again enter something here, now we have another effect that rendered this, and it's ready to go. So if I click register, it will generate the keys, private, public keys, and set up the encryption. And this one here, once remembered, will be your portable private key seed. So you can enter it on mobile anywhere. It generates the same, deterministically generates the same private key, and so you can have access to your encrypted data from anywhere. Anyways, let's see what this. Okay, so this email effect is just like if we go back, you can see the different states. This is a different effect, the reload effect. So the reload effect is, this is before and after. You can see what happened. This is a delta in this state. And if we want to go back all the way to the DOM and see what remains, this is the only thing that remains. Everything has been re-rendered by other effects. So this is good for now. What I'm wanting to add is evented try catch, global try catch, that will allow us to trace the effect of events even when errors happen in our program, which will happen, of course. That's the whole point, is that aids in debugging. And then we can see not only the initial state but also the final broken state of the program. Right now it only displays initial state and finished state for every effect, and it's cumulative. So if an event leads to an effect, and the effect is the combination of many things that happen on the screen. It's not, an event may naturally leads to one effect, but the effect is many things that happen. Several renderings, re-entrant, asynchronous, all of that, concurrent. And so what we want to do is not just get the state before and after, but the state in between when the program breaks. We want to capture that state as well, and show the broken state, and so that we can understand, and where it's happening, which effect caused it, and we can find out how to repair the program by looking at the state and saying, oh well, this field shouldn't be like this, let's see where we're setting it to this, and then we can understand the code where the error is happening. It really goes around having to step through code and asynchronous control flow. It's kind of impossible to debug asynchronous complex asynchronous control flows, going through the debugger and stepping in and out of libraries and all of that stuff. I find it very difficult. A lot of people resort to putting console log statements, logging versus debugging. But this is another means of debugging, making the program state transparent by mapping event to effect, and effect is composition of things that happen on the screen in the network or internal state, and also how the effect is mapped to the state, what part of state it interacts with, and what changes. And again, adding the evented try catch, and displaying the broken state when things break after an event happens is will be a valuable addition to this. So I look forward to doing that. All done.